welcome. Now today is part 2 of the Joystick Autofire Rapidfire Turbofire, whatever, project. And if you have not seen part 1, I strongly recommend that you see that first so that you know what's happening in this video. The link is in the description below, or the letter I somewhere here or there, I don't know. Anyway, let's continue with this. There's some changes actually to the project, well, some changes to the plan on the project. Initially, I was actually going to install the circuit in here, or in here, you know, one of these two. Now, things have changed. I am going to install a circuit in one of these, but not this particular one, because this one requires a 5-volt power a 5-volt parallel or a 5-volt power supply. As I said in the last one, the cable does not have the 5 volts going through it. So what I was planning to do today initially was replace this entire cable, including the DB9 connector, with the new wire. I can understand that can be extremely impractical, and it's just, there is another way. Now these zipstick joysticks, which actually have the Autofire built in, unlike this one which doesn't, what mashed my head about this circuit was the fact that it does not need a plus 5 volts. Now it's got 2 transistors there. How the freak does it not need a plus 5 volts? Now, my plan was to reverse engineer this and study this circuit, and then rebuild it, of course. However, what I've realized after some kind people have, around here and there in the Commodore Amiga group and also in the comment section, have explained, who know the circuit well and have explained what it is. Actually, it's more familiar to me than I realized. And I think eventually when I would have reverse engineered it, I would have realized what the freak it actually is. Now, where I've seen this circuit before is an LED flasher. It was like there's a outlet here, well, it was an outlet here called Maplin Electronics, and it sold these DIY kits. And one of them was an LED flasher. It's basically just 2 capacitors charging and discharging, and then they are switching these transistors on and off, in like a sequence like this. And that's basically how this Autofire is working. It's just like switching on and off, oscillating. And that's basically it. And a detailed, of course, this is like a really crude explanation of how this works, because I don't want to get into it too much, but that's basically what it is. And this is a circuit which I'm going to build and put inside here, actually put inside here and put a switch on the outside. Now today we're not going to deal with this circuit, we're going to deal with the 555 timer circuit, and I will tell you exactly why and what the advantage that has. So this here is a circuit which I built last week on the breadboard. There is a 200 ohm resistor there between pin 3 and the DB9 plug. So that will, I think, protect or just like lower the current a bit, because there is like current going in there. Thanks to somebody who suggested this in the comments. Okay, so since I'm not going to do an internal circuit today, I'm going to do an external circuit. So there will be like an external box with the Autofire circuit, with the circuit in there, and you can connect any joystick to it. So that's got its advantage, that you don't have to, mud every single one of your joysticks that does not have a freaking Autofire circuit. However, the pros to, and of course the pros to a joystick which has an internal circuit, is the fact that all you need to carry around with you is just the joystick if you're going to take it around. It's just built in, that's it. That's why everything has its pros and cons. But anyway, this has been brought forward now because I was confused about the external. I have no idea why the freak I was confused, because I actually sat down with a whiteboard and had a freaking session of drawing how the external circuit's gonna be. Because I searched around the internet and I came out with this circuit, and it confused me. It gave me the feeling that the only way to do this is to have an Autofire, as in literally you switch it on and it's constantly pulsing. And it took some brainstorming with a commenter to make me realize that I was just like going around the freaking world, head mashing myself, when the solution was just obvious. Sometimes it just takes that. So let's test out this circuit here, the external circuit, and we'll start building it. Right, so the only thing that we actually need to do here is, the only extra thing that I should say, is to add the ports so that we can just test it while it's on this board, while it's on the breadboard here. So let me get my nice box of delicious electronics and my breadboard kit, and we get the DB9s out. I have DB9s here, which, you know, for test purposes only. You can see the entire 9-pin. That is the plug, and that is the socket, and they are breadboard friendly. Basically what this does, it just taps into the fire button line, which is not this, which is the yellow one here. So we need to just connect this to. Okay, so this thing here, this is the plug. You plug it into your system, and the part that is coming out of pin 3 and going into here, into the computer, that's this yellow part, the resistor there, yeah? At the other end of the resistor. So that connects to that, that's cool. Now the other part here, the part that goes to the button, so that the yellow one on this side, on the socket, the part that goes to the joystick, that connects to pin 1. And yes, I've color coded them. You know, there is like a method to all this nice pretty colors. It just makes things easier for me because I'm visual. Now for the plug, the ground from the plug, which naturally is black, goes into the ground rail, and the ground from the socket, of course, goes into the ground rail also. And of course the plus false from the socket, the joystick, goes into the plus false rail here, and from the plug goes also to the plus false. So those are connected, and the rest of the pins from each of these socket and plug just link to one another. So let's do it here. Orange goes to orange, and finally we have the up, down, left, right. So you have something that looks like that. So we're pretending that this is the computer. So plug the joystick connector into that, and turn the computer on. So we now connect the joystick into it, into the socket. Don't know if you can see that there or not, but that's flashing. So that's working. Fantastic. Up, down, left, right's fine, and then you have that. And you can bypass Autofire by just like closing the switch, and it just goes through. You take the switch off, then it's Autofire. And you can adjust the Autofire speed. So let's start having fun and start soldering. First things first, this is quite a small and simple circuit, so we're not going to need a piece of matrix board so big. It's just going to be, you know, around this size. That'll be fine as long as it fits in the freaking box. That's fine. Just bend one pin on either side so that the IC holder doesn't come out. We just put it in this thing and start soldering. Okay, so let's just identify the components here. There's only like 2 major components that need soldering onto the board, to be honest. So one is this 10K one, which is connected to pin 6, but before that there's a joint, so just leave a hole. On pin 3 there is a 200 ohm before it goes to the pin. 200 ohm here. And pin 3, the top is this notch, pin 3. So we have resistor connected there at pin 3. Now we have the 10K, which is here. I can just take them off the breadboard. There's no problem. That's the good thing, you know. You can just like start picking them off the breadboard and doing them that way. So you can, yeah, one space again, and just put that in there. So that's pin 6. Bend them slightly underneath, so there is there's no risk of them falling out. So after pin 6, the resistor, there is the capacitor which goes to ground. So let's just put that in as well. Okay, so that's done. We just need to turn this around. Start soldering everything in. So here you can see pin 6 connects to pin 2, just like a direct connection there. So let's do that on the board now. Now pin 6, just make sure that you're aware that this is corresponding on this side of the board, that it's reversed on that side. So pin 6 is this one. A few times I've done it so this, thinking this is pin 6, but when you turn it around, I've just done it on pin 3. So yes, I did that when I was doing my stereo SID, my dual SID mod thing. I got it wrong way around, so I had to kind of messy. So that is pin 6, and that is pin 2. So we just need to connect them. So I just want to connect them, so you just make dots first. And that's it. Okay, so pin 2 there is connected to pin 6. Don't know if you can see that clearly or not. It's very shiny. Okay, so we've done pin 3 already. We did the resistor. Pin 4 goes to plus volts, and also pin 8 goes to plus volts. So pin 4 needs to connect to pin 8, and yeah, there's no space on the thing, so we can just, you know, jump a wire across between them. Okay, so that's not pin 4. That's not pin 4. I almost did it again. That is pin freaking 5. This is pin 4 because it's reversed. Okay, so pin 4 goes to pin 8, so it's bridging there. So we take pin 8, we connect pin 8 to a terminal, a plus volt supply. Actually, let's make 2 pins, 2 terminal pins next to each other. Just makes things easier because we're connecting both sides of the cable, the DB9 socket and plug. So we have 2 ground pins, 2 plus 12 pins. Right, okay, so what we need is a pin for the... Okay, let's just do the freaking input-output pins. Now pin 8 goes here, which is that variable resistor. Now, I'm not going to put the PCB one. I'm going to put a variable resistor, as in a huge potentiometer, on the case. So, you know, you can adjust the autofire rate or the rapid fire rate, you know, externally. Just heat it up enough so the solder gets attracted to it. Okay, so I've more or less built the circuit here. We just need to sort out the, you know, everything else around it. Okay, the input is just, I need to prep this wire here, and the input is, I'm gonna be, you know, making a plug that plugs into the computer. The output is gonna be a socket, however, that you can plug your joystick into, if you know what I mean. So let's prep this wire first, the length. So basically we just need 2 terminals for the switch, and that terminal, the switch will just short out pins 1 and 3, therefore just giving a straight path to the autofires, if you know what I mean. So just 2 terminal pins will be fine for that switch. Okay, so let's attach 2 wires to it. Might as well just put the switch in now. Actually, might as well connect this in now also. So we've soldered the wires on the switch. Now we just need to kind of solder them on the board. Terminal pins. Do the variable resistor. So it's going to be this and this. No, there's those 2. So let's join the center up with the end of one of them. because that's one end. This is why I use terminal pins. It's just so much easier soldering and desoldering, and it looks neater as well, in my opinion anyway. That is going to be positive, that is going to be negative, that is output, that is, well, the tap through really thing. Okay, so let's now Autofire. Okay. Okay, so all these other wires are going to go right through to the joystick except the fire button, which is this. So we need to cut that in half and strip it and join it under that. The rest of these go there. Oh, no, not the rest of these go there. We need the plus volts. We need the freaking power, don't we? So the power and also the ground go up here too. Freaking here's me. I'm gonna power the circuit. Okay, so this is the input side done. Now what we need to do is do the other side. What I'm going to actually do now is connect the socket to this so it can just be a pass-through. So I'm just going to connect it directly to that because I can cut the hole out for the socket, you know, afterwards. It's no problem. I can just solder this now. So what we need to do now is tin these pins. Okay, that's done. Now I'm going to connect these to that, and I'm going to keep my color code, you know, keep a certain color code. The yellow one is fire. I wonder why. Then there's positive and negative, red and black. And then this is fire too, the button B, which you get on Amiga and Commodore 64, you know, games or joysticks. This one, white one, is fire 3, which I don't think is ever used. It's just that extra pin, it's pin 5. This is, purple is right, gray is left, and blue is up, green is down. Yeah, more or less. Let's see, I remembered it at least, so the colors help me. I'm visual. Just to make something clear, whenever you see my diagram, my pin-out diagram of a DB9 connector, it is actually of the back side, the back soldering side of a socket. So that is the pin-out. It's like 1 to 5 and then 6 to 9. Actually, I would like to say a few words in response to quite a few comments I've been getting lately, and also with response to the stuff that's been going on lately around here. Left is gray. I'm gonna have to put use brown as purple because there's no purple here, so purple is brown in the leads. Why aren't there more women into this? I will, after experiencing what I experienced this year and late last year, I have to say, I have to be completely and utterly honest with you. Pin 5 is white. 2018 and, you know, since mid 2017, I've felt how difficult it actually is to make this YouTube channel and to be accepted in the society. I know on the surface it seems like I am, but underhandedly I'm not. And you know, that I feel that. There's just no escaping that. And I'm gonna be, you know, brutally honest. It is hard. We get accused of all sorts. We get judged. There's always, you know, there's always a theory that there's some motive behind it, you know, that there's some feminism or something. To be honest, let me be clear, I cannot stand the hardcore feminism, just the same way as I cannot stand misogynism. To me, they are one and the same. This has been my interest since early, you know, whenever. Now, if you think this is too complicated for women to do, why don't you try doing crochet? Actually, I find this easier. I don't have a black. I need to get more blacks, so I'm going to use a blue instead of a black. I will link you to the talk by a gentleman from the Computer Museum who spoke about how, you know, part of his talk is about how women have been pushed out of computer history. I mean, after all, why can't we do this sort of stuff? We're human, also. You know, just like you. So, I cannot see a problem with this. Just notice that I've forgotten something here. Just the track from pin 7 to this. So it's obviously, you know, not gonna work. Anyway, so yeah, the underhanded stuff, as I was saying, which is pretty friggin' toxic. The type which smile on the surface, who are like, you know, pseudo friendly on the surface, but kind of constantly trying to show me that they can do better, or men can do better, or they're more important, or that men are more important. You know, I've got those types too. It's been quite an experience, I have to say, since I started my channel. I came into it with rose-tinted glasses, thinking if I'm nice to people, they'll be nice to me. How ridiculous is that? Certain people from now on will notice my attitude towards them change. Because I have self-respect. Yes, I'm gonna speak up because it's not nice to be insulted. It's not nice. I mean, you cannot just keep ignoring it, because if you keep ignoring it, it will give the impression that it's okay to insult people like this. It's not okay to insult anybody. Woman, man, anyone. It's not okay to insult anybody. Ignoring it just made it worse. So I'm gonna speak up and say it. Because this is my space and I have the right to have it here. Yeah, as I said, it's hard for a woman to be, you know, in doing this sort of stuff in this community, because we get accused of all sorts, you know, and it's not nice. There's got to be something wrong with us for us to do this. And of course, for me personally, I don't want any trouble unless absolutely necessary. So to those who are either outwardly or underhandedly, even if they're nice to me on the surface, underhandedly, if they are being quite demeaning to me, they will soon notice me pretending they don't exist. Because that's how I deal with things at first. I'm not interested. I will keep myself to myself, and I will ignore or blank people out who try to insult me. Unless it gets too far, and I will, don't know, fight back. Okay, so we've got this done. Oh, nice primary colors. So we have this. Now you're probably wondering to yourself, why is she saying all this? Because it's not normally that I talk this way. There is, besides the amount of comments, or the type of comments I've been getting recently, and the type of things I've had said to me, which, you know, I have every right to respond to. I'm going into surgery on Tuesday. So, you know, there is a growth on my little finger here. As you can see, there's clearly a difference between this and this. I can actually feel, you know, a lump here, and it's growing and getting bigger. It's probably benign, there's probably nothing to worry about, you know, but of course I'm gonna go under anesthetic, you know, general anesthetic, and all that. And also, there's been a few things happening that have actually got to me. Call it underhanded online bullying. And yes, from this community. And yeah, that has caused my heart rate to kind of go up a bit too high. So, and I found out only when they checked me, you know, as a pre-check for the surgery. So yeah, I think something needs to be said if that's the case. You know what I mean? Health comes before anything, and yeah, you don't know what's going to happen with a general anesthetic or anything. So I just want to say my part to these questions that people are asking, and they're very important questions, because if something is hindering me as a human being to pursue her interests, whether that be Amiga, whether that be electronics, or anything that is considered masculine by society, to this point, the point that it's making me ill, I think it's probably best saying it out loud. You know, I've got nothing to lose. It's not just me who's into electronics, there's so many other women Jerry Ellsworth comes to mind first. I admire her. She knows way more than I do. My knowledge is literally nothing compared to hers. Everybody has their own story. There's a reason why everybody is into what they are into. We don't have to conform to society. And I'm somebody who just doesn't conform to society. Because society really hasn't done much for me, if I'm brutally honest. So that's done. We have everything done. Actually, it's quite quicker than I thought it was going to be. Let's test this out now. Actually, no, let's not test this out now. Let's put the freaking plug on first. So yeah, another. So I hope this kind of answers the questions that a few of you have asked me recently. Why aren't there that many women into gaming and retro and vintage audio and electronics? Because we're not welcome. That's brutally honest. We're not welcome. And you'll find that you will only notice that when you notice the underhanded things. Saying all this, I wish to thank, and I'm really thankful for, and I wish to thank the male friends which I have who genuinely, from their core, support me and are happy about me. And I know many of my viewers do also. They encourage me, my patrons. Normally my channel mentions none of these issues. Literally none of these issues. So I think sometimes it needs to. I like the look of these plugs actually. I like them better than the other plugs. There you get. Now to that one guy who keeps, even after all this time, keeps making fun of me for going downstairs and melting a DB9 connector hole through here. This is why I didn't do it with the Dremel, because it creates, I'm not good at it, and it creates a big dirty freaking hole here. I mean, it'll do, but it's not the most ideal. I mean, one thing which has worked to its favor is this. You know what? Whoever invented Millipet, thank you so freaking much. It's a lifesaver, really it is. I'm just like filling in all the parts that, you know, I cut by mistake, because that blade was the smallest blade I had, but it's just too big. There's always some left. I need to order some more actually. It's Milliput Black. Just in case you want to order it. It's so handy. It's just like epoxy putty. You just like mold it into any shape and it turns freaking rock solid stone. You know, eventually. Okay, there it is. It's a squeeze, but it should go in. Let me just try and... Okay, so that is done. Let's put the red button back on now. That's the Autofire button. And the dial is gonna be this once I find the freaking screw for it. Okay, so let's test this Autofire thing now. And this is like Autofire off, so you have to keep pressing it. Ah! Okay, so let's turn it on. That is actually slowest. The variable resistors are one side. Now let's slowly start turning it up. It's not working kind of, you know what I mean? It's not smoothly working, but it's kind of somewhat getting faster. Now that it comes to a point where it gets really fast, like this. Now, yeah, it gets at this point where that happens. It's almost like it's thinking Autofire is off. That's because it's oscillating so fast that the Amiga is just registering it as a constant button press. So on the other end of the variable resistor, it's that. It's like Autofire off almost. Ah! That's working really well, actually. Fantastic. just because I really want to hear the music. Let's take it all the way down again. I still need to do a gameplay of this actually. I like Turrican 3 or Mega Turrican on Sega Genesis or Mega Turrican. I like the colors and this one. And especially the music. Okay, so we've established that the Autofire works and everything's working fine. Again, let's cut the Autofire. Yeah. And put it back on again. Fantastic! So there we go, that is my Autofire project build, and I'm really happy with the way it looks and everything, as well as how it works. Actually, there was something I had to modify in the circuit. I will show you that in a second. This variable resistor here. Now if you remember, I didn't have a 10K variable resistor at the time, so I had to put a 20K in there. Now, I remember when I was playing, when I first initially, put it on, tested it, I take it all the way up to the end, and it'll do like a lot of things. As you can see that notch there, it will do a lot of things in this kind of space. And then all this, the rest of it, when you turn it, it literally does not do anything. Basically, it's just like all the freaking effect is like compressed all the way up to there somehow. So then I managed to find, a 10K. And then what happened is that, the range was like up to here, like I'd say a third of the way. And the rest of it, again, it wouldn't do anything. So I was trying to look for a 5K, work my way down, but the only one I could find was a 1K. So this is actually a 1K, and 1K is actually the optimum value. It will react all throughout this range. But I would recommend, so I've changed that to 1K, but actually I would recommend a 2K. Thank you for watching and for your likes and your shares. Do leave your thoughts in the comments below, and don't forget to check out my other videos and do subscribe for more. Also, don't forget to hit that bell icon because YouTube is screwed up, as always. For now, I will say adios. For their generous donations, I would like to say a big thank you to my patrons. Alhunt, Alex, Andreo, Anthony Proctor, Boris Matishin, Brad Hansen, Cameron Armstrong, Carrie S. Turner, Karsten Lervad, Casual Commodore, Counting Virtual Sheep, Electronscape UK, Eric Andre, Espen Galbeck, Gav Messingham, Jeffrey Major, A Hazemaker, James Burr, James Hare, Jan Beta, Jason Cadever, Jim Leonard, Just 80, Mark Amorin, Mark McDonald, Matthew, Matt Shepkar, Matthew Simpson, Mickey Holm, Obraxis, Patrick Ekman, Peter Lingbeck, Rancy, Risky Flyer, Robert Minnis, Rafi Otterstein, Roy Gelotti, Rudiger Stiedel, Steve Jones, Sophie Leroy, Stuart Evans, Thomas Brezina, Thomas Muller, The Deeply Cynical, Tina Stormcaller, and Wayne Marsh. If you wish to support me on Patreon, the link is in the description below, as well as links to my patrons' websites or YouTube channels.